Greetings and welcome to my new calculus channel. My name is John Gabriel. So in my previous video, I talked about the classical Greek derivation of number and how that it's flawless. In other words, if understood correctly, unlike set theory and ZFC, it doesn't require axioms or beliefs. And so what I'd like to do in this video is to take a look at some of the other mainstream ideas and notions about number. So, if we look at, and believe it or not, if we look at the Wikipedia article on quantity, which really shouldn't have been part of quantity, but should have been part of the article on number, we'll see that there were several ideas about number, and most of them were sort of on the right path, but not actually correct. So, in other words, it just shows that mainstream academics never understood the concept of number. So, we'll first look at Aristotle, that anal retentive Greek philosopher, who wasn't a mathematician, by the way. He said quantum means that which is divisible into two or more constituent parts in his metaphysics, of which each is by nature a one and this. In other words, one and some more. A quantity is a plurality if it is numerable. That's absolute rubbish. A magnitude if it is measurable. So obviously you can see that what he did was he in his first attempt he immediately injected obfuscation into the understanding of number. Um, Aristotle had no idea what is a magnitude or a number, and he had no idea about mathematics in general. He was not a mathematician. Okay, and I'm not going to waste much time on him. And although he had uh, exceptional skill in writing and in philosophy, he really did mathematics a disservice. Now, in his Elements, Euclid said the following, and this isn't a good definition. But by the way, Euclid wasn't trying to define number in this particular definition. This is definition 3, book 5, where he says a magnitude is a part of a magnitude. That's a circular definition. And I think he didn't care to define magnitude because it was a common Greek word. Every Greek in ancient Greece knew what meathos means. Even every Greek today knows what meathos means. It's just a concept of size, it's not a number. So, uh, and this quote here is wrong. For Aristotle and Euclid, the relations were conceived as whole numbers. It's totally wrong. So let's see what John Wallace has to say. He says, when a comparison in terms of ratio is made, the resultant ratio, now that's gibberish because, I mean, you have a ratio, namely with the exception of the numerical genus itself, leaves the genus of quantities compared and passes into the numerical genus, whatever the genus of quantities compared may have been. So I think that Wallace was teetering on understanding, but what did he do? He basically wrote a lot of incomprehensible rot. Okay, that was what he wrote in Mathesis Universalis. Now, I think what he meant is what I gave you today. And what I gave you today, surprisingly, which hasn't been deleted from Wikipedia yet, is a number is a name given to a measure that describes a ratio of magnitudes. So obviously I wasn't able to add this to the article section. And I'm surprised that it's still in the talk section because every time I suggest something, the fools of Wikipedia delete it immediately. Okay, so that's what Wallace had to say. Then what did the great Newton have to say? Okay, so let's read. He says, by number, we understand not so much a multitude of unities. And there's a reason Newton said that, because Newton wasn't just thinking of the counting numbers, he was thinking of all numbers. In other words, the numbers that weren't necessarily a multiple of the unit. So he says, as the abstracted ratio of any quantity to another quantity of the same kind which we take for unity. So again, Newton didn't understand. Okay, he was about as good as Wallace, maybe a little bit better than Wallace. But now this is where the understanding of numbers stopped. After this, nobody even attempted to define number until I came along. And I finally put it all together for you. Here it is. A number is a name given to a measure that describes a ratio of magnitudes. And that definition is described in my book called The Ultimate Book of Numbers, which is free and you can download from academia.edu. You will learn more about number and mathematics than you have learned in all your school and university years. You just have to have an open mind and to read this slowly and carefully, thinking about the concepts. Now, I'm not a natural born good writer, so some of the text may seem a little tedious or laborious, but you just need to endure all the way to the end, and I promise you, you won't be disappointed. So, on Discord, we were discussing the subject, and someone said, I like the way your last video explained how set theory partially mirrors the evolution of number. People think that you're just discounting whole fields of math for no reason when you're just pointing out where they're wrong. So this guy gets it, okay? And then I answered to him and I said, I was initially open to the idea of a new foundation for mathematics, largely because I, like many of my mainstream colleagues, did not understand Euclid's elements in my early years. Excuse me. The more I tried to comprehend the modern set-theoretic foundations, the more I realized they were nonsensical and based on belief, and full of contradictions and paradoxes. And although I knew many of Euclid's propositions from high school, there were still many I didn't know, as high school curricula covers very little, only what the mainstream morons think relevant. It turns out the most important aspects are either covered incorrectly or not at all, specifically the derivation of numbers, which is the focus of books 1 to 6, and the prologue, which was written by me and should have been written by Euclid. But remember, Euclid was a scribe. He was simply recording the knowledge of the previous Greek mathematicians. So what he did was exceptional, and of course, it's unfortunate that he didn't write a prologue, but I've written it for you. And the prologue can also be found at the same site that you see this article here. So if you go here and you search for prologue, you'll find it, the Revised Elements Prologue. Okay? So now, studying the elements was a turning point for me. I no longer assumed the mainstream was correct and began to question all of their beliefs, refusing to accept even the simplest notions. One could say that this was my Jerusalem moment, in a manner of speaking. I was blind and suddenly able to see. The first epiphany was followed by many others, and gradually the dominoes of mainstream ignorance began to fall. I was not alone in my thinking, but those with convergent ideas didn't care to further investigate and to research these problematic concepts in mathematics. So gradually, the task fell on me as an iconoclast. It wasn't easy, but being the natural born Spartan that I am, I welcomed the fight and was determined to finish it wherever it might lead. I'm happy to say that there are a few dozen people who fully agree with my ideas, and I imagine that number will increase My only wish is that I'm around to see this happen. So that's basically it. I hope you've enjoyed this little follow-up presentation on the Greek derivation of number. If you're not already a subscriber, become one. Click like, follow me on academia, tell your friends about this, spread the news. Till this very day, after I think 8 or 9 years, I haven't earned a single penny on YouTube. And I don't think I will unless my subscriber list increases. So it costs nothing to subscribe. Just hit that subscribe button and click like so that my videos are welcome by others as well, since the YouTube algorithm also takes the number of likes into account. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.